My name is Tom Pagano. I'm the project manager for the Atmospheric Infrared Sounder at NASA's Jet Propulsion Laboratory. We develop data products from the Ayres instrument, and we provide these products to the scientific community. And the raw data from the instrument is also used by National Weather Prediction Centers to improve weather forecasts. So Ayres was new in that it was what they call hyperspectral infrared. It measures the infrared spectrum from 3.5 to 15.4 microns with resolution of about 1,000 to 1, which means the wavelength divided by the bandwidth is about 1,000 to 1. So it's very high, enough resolution to be able to resolve the water vapor lines and see the carbon dioxide features, so we can do temperature sounding on that. So it was the first of its kind and was launched in 2002 on NASA's Aqua spacecraft in the A-Train. We were the first in the A-Train, and it's been operating successfully ever since. And the data from Ayres goes to, like I said, NWP centers worldwide, and it's had some of the highest impact of any single instrument to the operational forecast. The Ayres instrument and the follow-on, the CIRAS instruments, they're fully functional science class instruments, very capable, very accurate, very expensive. So that causes some consternation when you have to sustain this, several $100 million project over decades. And then you've got to pay for a satellite, you've got to pay for the launch, and after all this builds up, you're talking about $1 billion satellite or more. We've been working on Ayres for 15 years or so, and we realized that maybe 80% of the information that you get from Ayres can be achieved with just the midwave region of the spectrum, because we have water lines, we have temperature, CO2 branch for temperature sounding, and we can do temperature and water vapor sounding. Actually, we've demonstrated temperature and water vapor sounding with just the midwave. So what that does is it allowed us to shrink down the optics. And with new technologies in infrared detectors and new technologies in cryogenic refrigerators, and of course new technologies in satellites and power systems and all that goes with the satellite, we're able to shrink the size of the measurement down to a 6U CubeSat, which is one U would be 10 centimeter cube on each side. So 6U, imagine, is 2 by 3 by 1 of these things. So it's a pretty small, like shoebox. The thing about the infrared spectrum is that there's a lot of information in there about the gases in the atmosphere, because everything absorbs radiation. So we can see different gases like methane and carbon monoxide and even carbon dioxide. So this might be a paradigm shift. I'm hoping it does actually allow more scientists to be sort of the lead on their measurement, rather than being part of a giant team with a giant mission and being one guy, just a cog in a wheel. Now he can kind of design his mission and actually get it implemented affordably. So I believe there'll be more science principal investigators because there are more of these smaller satellites that can meet their unique needs.